All right, let's do a little bit of work on our UT Quest assignment on balanced forces. You had a number of pulley problems, and I want to go over one of those. And the key here to this whole assignment is this word right here, balanced forces. Balanced forces means that they all have to cancel out and equal zero. All right, let's learn a little bit about forces in a cable or a rope. And this is the big deal. If I have a cable or a rope, then the tension in that has to be the same throughout. I can't have one part of the rope that has a certain amount of tension and another part of the rope that has another amount of tension. So if I have 100 newtons of tension in one point, I must have 100 newtons of tension in all points of the rope. That's just the nature of ropes and cables and things like that. So how does this apply to a pulley? Well, a pulley, all it really does is it just changes direction of the rope. I know in middle school you're taught that they do all sorts of strange and wonderful things, and yes, they do, but they do it because of the fact is I have this tension that's the same throughout. All right, so what does that mean in this simple pulley? Is the tension in these 2 points must be the same. All right, so what that means as far as mechanical advantage, I now have 2 forces acting on this pulley with 1 rope. Whereas if I just tied the rope straight to the pulley, I could only pull it on it with force T. But if I wrap it around the pulley, now I'm pulling on the pulley with force 2T. All right, same thing in a more complex pulley problem. If you'll note that this rope is just wrapped around 2 different pulleys, but from physics, the tension in the rope is the same throughout every single point along the rope. Okay, so how is that going to help us solve this problem? All right, well, let's take a look at our problem. We have problems like this and some variation thereof, but the method that we're going to use to solve it is going to be the same. All right, we're going to start off with a free body diagram of the pulley. All right, well, I have this suspended weight that's pulling down on the pulley. Now, notice in these problems, we are given our data in weight, not in mass. Weight is a force. I do not need to multiply it by 9.81. It's already in newtons. All right, now let's apply what we know about pulleys. All right, I know that whatever this tension is in the pulley, in this rope, it has to be the same throughout. So I have to have the same force acting on one side of the pulley as I do the other because it's a longer rope. All right, now I'm ready to go to Newton's second law. Now, this entire exercise is balanced forces, so that means I have no acceleration, so this side of the equation becomes 0. All right, now let's look at F net. I have 3 forces. I'm going to call my upward forces positive, my downward forces negative. Now all I have to do is do a little bit of algebra and solve for t, and then I'm done with this problem.